Hello and welcome. I'm Marco Castellana, VP Products of Einstein, and today we're going to learn about Einstein Predictions. Einstein comprises many different components. Indeed, there's an Einstein for every cloud at Salesforce, from Sales Cloud to Service Cloud to Marketing Cloud. But Einstein Predictions gives you the ability to make your own custom predictions. Today, we're going to focus on one component of Einstein Predictions, that being Einstein Prediction Builder. For those of you who would like to follow along, you can do so by going to this link. This link will send you to a sign-up page that allows you to get access to a Developer Edition org in which Einstein Prediction Builder will already be enabled and which will already contain the data that we're using for today's demonstration. We also have a trail. This trail, called Get Started with Einstein Prediction Builder, will follow along with this video. And so you can also follow this trail if you would like to try Einstein Predictions yourself. Here we have an example of a custom application that has been built in my Salesforce org. In this case, I have built a custom application that allows me to administer my billing system from Salesforce. I'm sending invoices from here. The problem that I have in my business is that there are a number of people who pay their invoices late. And I would like to get ahead of that. I'd like to predict who's going to pay their bill late in advance so that we can reach out to those people and attempt to achieve an on-time payment. I can use Einstein Prediction Builder to make this prediction. Let's take a look at how that works. To get to Einstein Prediction Builder, I open up Setup here. When I have Prediction Builder enabled, I'll find that there is a card front and center on the setup screen called Einstein Prediction Builder. Now here I am in Einstein Prediction Builder, and I am going to create a new prediction. Now the first thing I have to do is give it a name, and I'm going to call it Will Pay Late. So I'm going to predict who is going to pay late, hence will pay late. Now I can make a prediction on just about any object in Salesforce, whether it's custom or standard. Now in this case, it is a custom object called invoice. I can segment my prediction. And there are various different reasons why you might want to segment your prediction. First of all, you might want to say, I would like to make a different prediction for California than for Nevada. So that's one reason why you might make a segment. But today, I'm going to make a segment to prevent trivial predictions. It so happens that I have some subset of my customers that are on an auto pay plan. They automatically pay their bill. And that means that they never pay late. So there's just no sense in making a prediction for them. And so I only want to make this prediction for people where auto pay equals false. And that's what I'm going to put in my segment here. Now we can go to the next stage. I have to have a field in the system in advance that reflects the thing that I want to predict. So in order to be able to predict it, I need to be able to report on it. And that means that in this case, I need to have a field that indicates whether somebody did indeed pay their bill late. Fortunately, in advance, I did create just such a formula field called pays late. Now I have to decide what are the records Einstein is going to learn from. The way that Einstein Prediction Builder works is that it uses your historical data and learns from that data. In this case, it's going to learn from the people that paid their bills late, but also from the people who paid their bills on time. And it's going to find the patterns that lead to late payment from that. But to do that, I have to tell Einstein what is my historical data. Fortunately, with invoices, that's relatively easy to divine. An invoice that is pending is something that hasn't been paid yet. I don't know whether it's going to be late or not. But if it's not pending, that means that it's already been paid, or it's already been paid late. And so I'm going to use my invoice status, and I'm going to say where invoice status does not equal pending. And so Einstein is going to use all the invoices that are not pending to learn, and it will make predictions on all the invoices that are pending. Now at this point, I should take a moment to check my data. Over on the right-hand side, we have this data checker. And this data checker will count the records and ensure that I have the minimum amount of data for Einstein to learn. Einstein requires at least 400 records to learn from. When you're predicting a yes and no question, you need at least 100 yeses and at least 100 nos. In this case, the yes and no question is, will the bill be paid late or not? So I need at least 100 examples of late bill payments and at least 100 examples of on-time bill payments in order for Einstein to learn. And finally, the last number that it shows me here is the number of records that it's going to predict. In this case, I have 129 pending invoices on which Einstein will make a prediction. Now, if we go on to the next screen, what fields should Einstein learn from? By default, Einstein will learn from every field on the object. So again, what it's going to do is look at my historical data and learn from that historical data, and it will consider all the fields of that historical data. Now, there are various reasons why you might choose to remove a field. Generally, we recommend that you leave as many fields in as possible to give as much as possible for Einstein to learn from. But sometimes you might want to remove unwanted bias, for example, for personally identifiable information. Now, in this case, I don't have any kind of unwanted bias like that, but I do have kind of a funny field in here. It's a late fee. Now, a late fee is actually a type of bias. It's called hindsight bias. I would only ever assess a late fee if a payment were in fact late, and that means that the late fee field could only have been set in hindsight, after we knew that somebody had paid late. So since that field represents hindsight bias, I would like to remove that from the set of fields that Einstein will consider. And so I've done that here by taking that out, but I'll leave the remainder in because Einstein will figure out the rest. And now it's asking me for a field label because Einstein is actually going to create a custom field in my object, in this case in my invoices object, to store the prediction. And so I'm going to add a field to the invoice object called will pay late, where this prediction will be stored. When you ask a yes and no question, the prediction comes in the form of a probability. In this case, this will be a number from 0 to 100. That represents the percentage probability that this invoice will be paid late. And that is what you'll find in this field. And now we're done. This is our overview page. I can take a look through here and make sure that everything is as I had wanted it. I can again check my data just to be sure. And then I can build my prediction. Once you've finished building your prediction with Einstein Prediction Builder, it may take between a few minutes and a few hours for Einstein to learn from your data. That all depends on how much data it's learning from. But once it's done, you will find a row like this in Einstein Prediction Builder. And in this case, we see some basic information about how my prediction turned out. In this case, it says, my prediction is in great shape and it's ready for review. So before this actually begins making predictions, I first have to review the scorecard and make sure that everything looks good. So let's take a look at the scorecard on my prediction. Well, it does indeed look pretty good. So first, we can see this little dial here that tells me the quality, the expected performance of my prediction. And we are well in the green zone, so that's good. On the right-hand side, we can also see some information about what Einstein has learned. Certainly, it's found that one of the most important predictors is if you've paid a previous bill late, you might pay another bill late. But also your payment method is a predictor that it's learned. You can use the Predictors tab here to dig more deeply into what Einstein has learned. And we can find, for example, that credit cards are the most predictive of late payment, whereas those who pay by e-check and by wire don't have as much of a problem. But you can dig into that more deeply. So now that I've looked into my scorecard, I can go back into Einstein Prediction Builder and I can enable this prediction. Once I have enabled this prediction, Einstein will begin scoring. That means that it's going to begin writing predictions to the field that I had created. Once I've enabled my prediction, it may take up to an hour for Einstein to complete making all of its predictions on all of the rows of the object on which I made the prediction. Now, it's completed for me. And so I'm going to make a list view containing my pending invoices. And to this list view, I can add my new field, the Will Pay Late field. This is the prediction that I created earlier. And as we can see, it has the numbers in it just as I expected. I can now sort this. Let's say sort it in descending order. And now my accounts receivable team knows where to focus their efforts. Those with the highest predictions are the ones that are considered most likely to pay their bills late. And so if my accounts receivable team is looking to make the most impact in gaining on-time payments, these are the folks that they should focus on first. And that is how you use Einstein Prediction Builder to make custom predictions. Thank you.